Today, let's go over a medium question that was part of the 1 hour ago, the weekly contest. This one is called Sort Matrix by Diagonals, and it's pretty simple. As you can see, I did solve it by myself, so let's go over it. So you're given an n by n, so rows, columns, dimension of square matrices. So basically a matrix 2D list of integers. And what you want to do is return the matrix such as the diagonals in the bottom left triangle are sorted in non-increasing order. That just means decreasing order, biggest to smallest. And then the diagonals in the top right triangle, so right here, are sorted in non-decreasing order, which is just smallest to biggest, ascending order. So it's easiest to just look at the examples. So let's take this input and see what they mean. So it looks like what they mean is they want, first of all, we sort these. So 4, 9, 5, that stays the same because this is biggest to smallest, 8, 6, 1. And then 2, 7, from smallest to biggest. And then they want you to return the rows of the new matrix. So if you know how to get the diagonals, this is actually pretty simple, but you also just have to make sure that you are sorting correctly. So descending first and then ascending. So if we know that, let's go ahead and declare a variable to start at the bottom left, which is going to be 2, 0 in this case. And we're going to go upwards, and then we're going to go to the right. And each time we move up or to the right, we are going to go as far down right as possible. Okay, so until we cover all the cells in the matrix. So let's say start x, start y is equal to, what is this? This is going to be the length of matrix or length of grid, and then 0, right? So we're starting at 2, 0. And then we can say, because, so 2, 0, 1, 0, 0, 0, 1, 0, 1, 0, 2. So we know here that this y coordinate doesn't change, the x coordinate shrinks. So we can stay while start x is bigger than 0 because it's going to start at 2, right? So while it's bigger than 0, then we can, or bigger than or equal to 0, because this is still ascending or descending, we can say start x minus equal to 1. Let's print start x and start y. Okay, so let's make this here so that we don't get infinite loops. Okay, so length of grid minus 1 because it starts at 2. So 2, 0, 1, 0, 0, 0. 2, 0, 1, 0, 0, 0. Those are going to be sorted in descending order. So let's go ahead and try to do that. So let's call this, so before this x changes, let's say current row. And let's say, so we're going to clear this current row. And then what we're going to do is we're going to say now x, now y, because cool, now we got this coordinate, but now we want to go down right. So it's going to start at start x, start y, which is the current, let's say 1, 0, and then we're going to get 2, 1, right? So plus 1, plus 1. So while now x is less than the x-axis and now y is less than the y-axis, the width of the rows, so the width is this, and then we're going to increment both, and we're going to append grid now x, now y. Okay, so let's print cur row and see. So out of range. Okay, so if now x is less than, or maybe we could do it like this, before the change itself, so we don't go out of bounds. Okay, cool. So now we got 4, 9, 5, 1, 8, 6. This needs to be sorted. So 8, 6, 1. So now let's say, right, so reordered. Let's call this cur row, or just, we can even just say cur row dot sort reverse equals true. And then now that we have that, we can just put them back in, right? So let's print cur row. This is going to be the final correct values. Now we just got to place them in the right place. So 4, 9, 5, 8, 6, 1. Cool. So now our job is to replace it. So we're going to do another loop exactly like this. And let's call this fx, fy, start x, start y, call whatever you want. Well, fx less than length of grid, again, and fy less than length of grid 0. Then now we're just going to place along this diagonal. So fx plus equal to 1, fy plus equal to 1. But before that, we want to make sure that we have a queue to pop left from, because we want the first. So we're going to 9, and then we're going to place 5, we're going to place 8, and then we're going to place 6, and then we're going to place 1. And so let's say C equals to dec cur row. So if not C, then we're done, right? That row, we placed all the elements. So just break. Otherwise, grid fx, fy equals to C dot pop left. And let's print this. Let's print this grid to see that this portion, at least this triangle, has been placed correctly. Okay, so it looks like it has, because so this triangle has been placed. Oops. 4, 5, 1. 8, 6, 9, 9, 5, 4. Okay, cool. Now we just got to take care of this part, and that's the opposite. We're going to sort in ascending order. That was the kind of mistake I made first. So let's do this again. So instead of starting at 2, 0, we're going to start at 0, 0. So start x, start y equals 0, 0. While we're going to go right. So while start y is less than length of grid 0, because that's the width of the rows. Right? And because we're just going to go right, so x is not going to change this time. Last time is y, that's not changing. So now we want to say the same thing, which is going to be cur row. So we can even just sort of copy this. So now x, now y. Okay, so now x, now y equals 2. Or let's first try to make this correct. Start y, let's print start x, start y. We don't care about this anymore. Let's get rid of those print statements. Okay, so 0, 0, 1, 0, 2, 0. Cool, that's where the rows are going to start. Now we can call this now x, now y. Equals to start x, start y. And again, while now x is less than length of grid, and now y is less than length of grid 0, because we're still going down to the right, and we want to make sure that's not out of bounds. So just going to refer to this now, cur row dot append grid now x, now y. The procedure is the exact same. Now x plus equal to 1, now y plus equal to 1. This is the going down right part. This is just going to the right. Okay, so right is just the y-axis increasing by 1 in each iteration. And then now, instead of reverse equals true, we can say cur row dot sort, because we want ascending order. Okay, and then the rest is the same. And fx, fy equals start x, start y, while fx less than length of grid, and fy less than length of grid 0. If not C, break, else grid fx, fy equals C dot pop left, because that's going to be the Q again, which is now from least to greatest, from left to right in the Q instead of the opposite. Same here. And then let's print grid finally at the end to make sure that we did everything correctly. If we did, then we can just return it. Okay, that doesn't look correct. Okay, this is, up to this point, this was correct, but why is this not right? Let's print cur row. Okay, so we got the 2, 7, and we got the 3, that's fine. Fx is start y, start x, start y. Zero, zero, right? Okay, let's do this. Okay, 0 is going to be the pop left. This is how I debug. Okay, so 7, 1, 0, 0, 1, 2, yep. So 0, 1, 2, yep. 1, 2 is 7, yep. Okay, that looks correct to me. Yep, we're changing the grid. Perhaps, did we mess up our diagonals? Because this looks correct, but this, like, almost correct. Non-increasing order, decreasing, and then non-decreasing is increasing. Yep, that's fine. Okay, row equals sort, yep, row. So everything was fine up to this point. And then maybe bigger than 0 instead of bigger than or equal to 0. Nope, nope, you still need 2, 0, 1, 0, 1, 0, 0. Okay, let's print the grid. I don't know why this is wrong. Okay, this is right. So it's 0, 0. Got 1, 6, 8. Okay. We want 8, 6, 1 instead. Maybe I got it backwards. This one's supposed to be increasing. Nope. 5, 6, 2, 4, 9, 1. Nope. Okay. 1, 2, 3, 9, 6, 7, 4, 5, 8. Why is this being changed? That's the crazy. That's the confusing part. Okay. Fx, Fy, start x, start y. Yep, that's fine. This looks correct as well. I don't know why this is being modified. Okay. The grid less than length of grid 0. Yep, if not C, break, otherwise. Fx, Fy, yep, pop left. Okay. Let's print the grid. Yeah, this is fine, but then something got... Well, this is fine, but something got messed up along the way. Now X, now Y. This is fine at this point. Yeah. Her row is fine too. This is weird. 168861. You know what? Maybe it's that. It's just that. Ay, ay, ay. Okay, so maybe. So if, I guess you can say if start x is equal to 0 and start y is equal to 0, then we sort it. Else curl row equals to, no, reverse equals true. Else curl row dot sort. Okay, cool, yeah, because this diagonal is still decreasing order, I forgot that. Okay, and now we got our grid, so we can just return the grid. And there you go, 100%. Passes all test cases. So this is my own solution. It's kind of messy and it kind of took a while because of the edge cases, but there you go, 100%, very efficient. And I hope this is a valuable lesson and experience for everyone, that debugging is really necessary and that's really how you learn. So thank you for watching, and please stay tuned for more and consider subscribing.